So that. Alrighty, let's change that, and we'll do this. Here we go. Hello, everybody. Hello. How's everybody doing today? Welcome back, everybody, to Math 126, 126. Good to see everybody here today. Hello, everyone. We're gonna wait a few minutes here and get a few people. Hey, there's Emma. How we doing, Emma? Are we doing fantastic here today? Hello. Good evening to you. Afternoon/evening, technically. Hey, it's Hunter. Hey, Hunter, how you doing? Time for some maths, indeed. Indeed, my friend. How was everybody's 4th of July weekend? Hopefully, everybody had a nice time, just relaxing, sitting, eating some good food. I hope so. I mean, I don't know, but you guys can tell me. Hopefully, you can. I don't know. I had you could watch the fireworks this weekend. Pounds of pork. Pounds of pork. So you had the big old barbecue, right? Big old barbecue pit. Had lots and lots of meats slash pork. It sounds just like pulled pork, whatever. That's cool. It was nice. How was your holiday? My holiday was great. It was wonderful. I had a great weekend. A nice chance to relax, just enjoy myself. Very, very chill, very easy. Very easy. Again. I was a bit busy though, and I'm gonna be pretty busy this week. This week's gonna be pretty busy. So work's gonna catch up with me this week, but it has everything to do with what we're doing here in this class. So we'll be talking about that here once we get the crew going in. You know, hopefully it's Emma and you get Hunter's here. We got hopefully Nick is here. Nick. Hopefully Nick is here. I don't know if Nick. And Lee Wen. See if Lee Wen is here. Nick's here. Very good. Very good. Excellent, excellent. I don't know if the other two are here just yet, but we'll have. There's Lee Wen. How we doing, Lee Wen? Hopefully you had a great weekend there. I'm doing great, Lee Wen. I hope you're doing good. Hopefully things have been relatively relaxed and chill with you. Very, very. Hopefully you had a nice time. Did you spend the 4th of July with family or anything like that, Lee Wen? Good, good. Hey, no problem. Of course, of course. Yeah, it was just having a grand old time. Grand old time. Who are we missing? I feel we're missing someone. I don't know. I just feel like we're missing just that singular person. Don't know what I mean. Just having a rough time. I just feel like we're missing someone. Maybe she'll come on by. Oh, Ashley's here. Hey, Ashley. How we doing? Hey, good afternoon/evening. Are you doing well? Hopefully things have been going rather well with you, Ashley. Maybe we are missing a couple more people. One more. I'm doing wonderful. Were you able to watch the replays from last week? Or were you here for the live stream? Sometimes people lurk around, so sometimes I don't see you guys. So I'm like, oh, okay, you guys were just lurking around. Totally understandable. If you got a chance to watch the replays or whatever, and that's cool too. All right. See if anybody else decides to join. I feel like I was here. Okay. Okay. I believe you. It's like sometimes, like I said, sometimes some people lurk there, just don't say nothing. I said that's cool. I respect that. No, I'm gonna be like, oh yeah, said nothing. Get out of here. No. I know. Sometimes we'll usually have like 4 people here, 5 people here, but if you guys are willing to make it out to these live streams, trust me, I hope you have a little bit of fun here in and along the way. That's what I'm legitimately. That's what I would like you to do. Enjoy a little bit, learn a little bit, and that is the goal. All right, now a little bit past 6 here. Let's go ahead and get started here. Yeah, let's do this. Okay. All right. Get this going. I don't know where Elizabeth is. She, I figured she'd be here by now. But maybe she's running a little bit behind, and that's fair. You know, maybe she's running like 5-10 minutes behind. Hopefully she'll join us if she's not here already. Oh, she's here. Okay, good. Hey, look. See, like I said, lurking around. Feel like we're missing a few people. See, there you go. There you go. Oh, fair enough. Okay, let's get started for today. Welcome back to Tuesday. Hopefully everybody had a wonderful 4th of July weekend. Alright, we have a couple things to certainly talk about here today. Plans that are coming up here shortly for you guys, and things that I will have to work on as well. So, I'm going to go to the big board here. See my lovely desktop on this thing, but I need to go to a specific page. So let's go over here. There we go. Okay. So what I want to show you here is this is the list of all the assignments that you see here, and of course the tests that I've posted up here along with the practice tests for those guys. Now the last test I haven't made up yet, but here's what I'm going to be doing here for the next week. Now the 29th, which is the last day, 29th of this month here, is the last day of class. Okay, so I just want to let you know the 29th is the last day of class, and so what I'm going to be putting up here this week is I'll be putting up here the chapters 6, 7, and 8 test. Okay, so that is what is going to be put up here. Now, I'm not sure how far we're going to get. It just depends on the pacing here from here on out. Alright, so I'm going to try and get through, of course, the entirety from Chapter 6 all the way up to Section 8.3. That is the goal. We'll see exactly how things go along. I'm not sure. If we do not get to those particular sections, I'm going to just eliminate those sections altogether as part of your homework score. I'll just give you a free 5 point. Okay, so that is what I plan to do if we don't get to those stages. Right, I'm going to try to get to those stages, but it just depends on what our pace is going to be at the end of the day. Now, a couple of other things to let you know about, of course, is also regarding the final exam. Alright, so I'll be simultaneously making up this last exam. I'll also be making up the final exam, which will be due, of course, the last day of class. The final exam will be consisted of questions from every single test. So basically all the questions from test 2, from the chapter 2 and 3 test, the 4 and 5 test, and the yet to be made 6, 7, and 8 test. Of course, I'm not going to use every question, okay? That's kind of crazy. All right. Instead, I'm going to take those pool of questions, those same exact pool of questions, and I'm just going to narrow it down to a bunch of questions for the final exam, and that's going to be your final. Okay, so I'm going to tell you exactly how it's, again, how it's being made is I'm just going to pull those questions, cut it down, and then that's going to be your final exam as well. So, again, you can take your own pace at that. That's perfectly fine. If you try all the practice tests here, again, the practice test will give you exactly the type of questions that will be appearing on the final. There won't be a practice final here per se because the practice test will be the part of the pool of questions that I will be drawing from. Okay, so just to let you know and give you a heads up regarding that. So once I have that squared away, which hopefully should be by the end of the week, as it does take me a little time to actually make up a test here. The system is actually pretty slow. So I have to like painstakingly things like one at a time if I'm not careful. Okay, so that is basically what I wanted to kind of say regarding the test there. Now, one more note here, and that is in regards to midterms. I had to give a midterm grade. I know everybody's been working on homework and whatnot. Basically, what I did is I just gave everybody a B. Okay, so I just don't want you to get surprised like, oh, I got a B even though I've done all the homework and stuff. I gave everybody a B across the board. Okay, because all the homework, all the scores for this entire class is up in the air until the very last day of the semester. So I'm like, okay, give everybody a B, and we'll call it good. So there you go. Everybody's got a B for the midterm grade. Basically, at the end of the day, you should just ignore the midterm grade as it doesn't mean anything, really, because this is more of a self-paced course in that regard. Basically, your final grade is going to be anything that you actually submit and put out. So that is essentially what we're going for here up to this point. So that is the update here. Are there any questions that you guys have over the tests or anything of the like? If you guys have questions, please feel free to ask, and I'll be more than happy to answer them. I want to be as transparent as possible with you about how things will go here for the next few weeks. So, I don't want to be like, oh yeah, you're this and that and the other. So, no. Again, any questions, please let me know so I can address them right away. If the music's a little loud, just let me know, by the way. Alright. Nope. Okay. So I'm going to move forward here if nobody has any questions, and we'll go ahead and get started with the newest material. Alright. So get ready, everybody, because today, ladies and gentlemen, today is lots of examples day once again. But fortunately, lots of examples aren't so bad. Alright, so let's take a good look here at some examples, and we'll see how things go. Alrighty. So today we're getting into Chapter 6, okay? So Chapter 6 is what is on the agenda here for today. And today we're going to be discussing here in Chapter 6, we're going to be discussing integrals, okay? Integrals are going to be our guy here for this particular section. Alright, now integrals are also called, another name for integrals are talked about as antiderivatives. So we've talked about derivatives at length. Now we are talking about antiderivatives. So what is an antiderivative? Well, if you think about matter and antimatter, well, kind of like the same thing. Matter and then the kind of the opposite, going the opposite way, antimatter. Yeah, kind of like that. Maybe not exactly. Oh, we'll run with it anyway. Run with the metaphor. All right, work with it. All right, so basically this says a function f is an antiderivative of little f, so a capital F of little f on an interval I if f prime, big F prime of x is equal to f of x for all x in the interval. Now basically you're like saying, wow, that's pretty confusing. Let's just boil it down into one thing here. All right, in summary, you are going backwards, okay, from the original function. Alright, so you're getting a function, you're going backwards. So instead of all that stuff we learned for derivatives, we're now working with antiderivatives. We're now going backwards here. Essentially what this thing is talking about in a very brief synopsis. Okay. The next thing that we'll talk about here is what the notation here is for integrals. Now the notation here for integrals is this kind of very fancy look, long looking S looking thing. Now if you were to actually draw it out, pencil for this guy, it's not so hard to actually draw out. It's just going to look like this. This is the integral. There you go. So not anything too crazy going on here, okay? But it is what it is. All right, so there's the notation for integrals, and then we put stuff on the inside or outside of that, and when we evaluate it using that. Now, let's take a good look here at some rules for integrals and see how they work. So that's the first part here we're going to promote here for the first hour here for sure, is just taking a look at how we can apply some of these rules here for integrals and how things can work in reverse as opposed to derivatives. First things first here is, what is the integral of a constant? Okay, so a good example of this is really quick. It's that if I have the integral of 2, if I have the integral of 2 dx, okay, so any integral of any number, okay, is going to be equal to kx plus c. Now, we're going to write this plus c here rather often, but again, if I have, say, the integral of 2, the integral of 2 is 2x plus this constant c. Now, you're probably wondering, why do we have this constant c here? Well, if I took the derivative of this, the derivative of this is 2. The thing is that you could technically, another way you could write 2 is, another way to get 2 is you could write 2x plus 3, and the derivative of this is 2. You could have 2x minus 7, and the derivative of this is also 2. Hence why we put this capital C on the outside here, in order to just show it can literally be anything that you add to, and you could still net the same result if you took the derivative of that particular function. So that's why that plus C is out there, and that's why we state it as any constant. Mind you, we're not actually going to be putting in numbers in those places unless we're directed to do so. Okay, so usually most of the time we're just going to have this plus C on the outside, and then that's it. Okay, unless we're directed to do something different. All right. Okay. Any questions about that so far? Any questions so far? Hopefully that's not too bad. Nope. All right. Like I said, hopefully this is going to be a little bit easier, but well, let's focus on the next part here. Okay. Probably wondering what we're going to be doing next. So let's look at number 4. All right. So of course, constants are really easy. Not much to think about here for constants. But number 4 is where we're going to use a lot of rules with. So of course, one of the rules that we used extensively with derivatives was the power rule here for derivatives. Once again, we have a power rule for integrals, and everything goes backwards. So what's the integral of x to the n dx? Well, this is equal to x to the n plus 1 power divided by n plus 1. So for example here, say I had the integral of x squared dx. Now if I'm taking the integral of that, I take that 2 plus 1, I add that 2, I add that to 1, and I put that over 2 plus 1. Okay, so what I have here specifically, and I have plus c. So then what I have here specifically is I have x to the third over 3 plus c. Or again, you can also write it as, by the way, 1/3 x to the third plus c. They're both the same thing. So just to let you know, just 2 equivalent forms of the same coin. All right. Okay. All right. Hopefully that isn't too bad. All right. But of course, we're gonna need to do a little bit more here. Now you're probably saying you're kind of pushing this here. I'll be like, yeah, I know. A lot of these rules here I'm gonna do pretty fast, but I want to do a lot of examples once we know all these rules. Okay, so bear with me here for just a little bit in terms of information dump. Once we go ahead and get through that information dump, then the rest of it will hopefully fall in place. Okay, next. What is the integral of a constant multiple of a function? So if you have a constant times a function, then basically you can take that constant and bring it outside. So if I took my last example here, and I said, all right, if I took, let's say I took 2, let's say, no, put that inside. Let's say I had 2x squared, and I wanted to find out what the derivative, the integral of that is, pardon me. I can take this 2, I can bring it outside here, and then I can just do the integral of x squared dx. So then what I would have is I would have 2 times, and then the integral that I have here, x to the third over 3 plus c, which would be 2/3 x to the third plus c. Okay, so again, the constant there doesn't really affect anything outside of maybe multiplying and simplifying some fractions on the outside. That can happen. All right. Okay. Other things that are applicable here, and this is using some of our derivative notes that we read from last time. If you add two functions together, you can go ahead and split those up into its own separate integrals. So again, just to highlight here, you could have x, let's say x to the fourth minus, let's say again, 2x to the third dx. And you can split that up into two separate integrals, the integral of x to the fourth dx minus the integral of 2x to the third dx. Okay, so you can, and then you can proceed to do whatever you need to do from there. Okay, so just to let you know, you can split that up that way. And finally, we have the integral of e to the x is still e to the x. That still doesn't change. And the integral of x to the minus 1, again, the integral of x to the minus 1, another way to write x to the minus 1 is 1 over x. And basically, in order to get 1 over x, you take the natural log of x. Okay, so the integral of x to the minus 1, or 1 over x, is equivalent to the natural log of x. Okay? So that is what we have there for that. Okay, so you got a screenshot of this or whatever. I'm going to move on here. I'm going to actually look at some examples here. Okay, so got a smattering of a whole bunch of different things, but now that we have the rules here, let's go ahead and start putting it together. Now, mind you, we're just going to be going over some simple problems here. Okay, so we'll be dealing with the more complex ones in the next section, but for this go around, it's not going to be too hard. Okay. All right. It is. Yeah, sorry, yeah, of course. Of course you can, Emma. No problem. Let me know if you guys need to see the question again. So if I went too fast, just let me know and I'll go back. Let me know and I'll go back. No problem. Okay, let's look at some examples, see how things work out, yeah? Okay. Actually, let's do that. Okay, let's go ahead and see, take a look here at number 2. Okay, so let's look at number 2 here first and foremost. Okay, taking the integral of 9 dx. What's the integral of 9 dx? The integral of 9 dx. What's that integral going to be? Okay, it's going to probably take a while if this is going to take a while. All right. Guys, got to get your rules down. Otherwise, this is going to be a long slog. I'm just going to be honest with you. So you guys help me out here. Take a look at the rules again. What's the integral of 9 dx? Okay, that's correct. The integral is 9x plus c. That's correct. Good. That's it. Like, don't make a mountain out of a molehill, guys. Like, I'm not asking for much here. All right, it's 9x plus c. Make sure you have these rules down. That's the one thing I'm gonna stress about here. These rules have to be made sure that they're put in place. Okay, so fundamentals first, and then we'll do more complicated stuff. But again, first things first here. Let's get the basics down. That's what I'm gonna ask you to do. As you can see here, 9x plus c is the correct answer. All right, let's try another. Let's try number 3. The integral of x to the 8th. It's the integral of x to the 8th dx. It's the integral of x to the 8th. X to the 8th minus 1/8 plus 1. So x to the 8th plus c, I get the same thing back. So read the rule here. What does the rule say? So I want you to follow this rule here on the left. X to the 9th over 10 plus c. 8x plus c. No, Liwen, that is going in derivatives. Not doing the derivative here. We're not doing derivatives here. Look at number 4. I want you to look carefully at number 4. I need you guys to put this together, one piece at a time. Okay? That's what I need you to do. This is super important. So I have x to the 8th here. Take a look at what we do here. It says the integral of x to the n. We're going to take that power. We're going to add by 1. We're going to take x to the 8th. And we're just going to add by 1. Okay? And then you're going to put that over that same power, which is 8, You're going to add by 1. And then you always have plus c on the outside. That's always true. So, all right. So this is like the important part here. So x to the so what I have here is that's correct. So I have 8 plus 1, which is 9. I have 8 plus 1, which is 9. That's correct. So I have x to the 9th for 9 plus c. That's going to be my final answer for that. Just that. Just x to the 9th over 9 plus c. That's it. That's all I'm asking you to do. I swear I'm not asking you big. It's just that's all I want to do. X to the 9th over 9 and then plus c. Yep. Okay, let's look at another one here. I'll come back to number 4 here in just a second. Let's look at number 5. Okay, look at number 5. The integral of x to the minus 3. Okay, so I'm going to write that one down. All right. Again, I want you to be sure that you guys got that crystal clear here. So can anybody tell me here, what is the integral of x to the minus 3? The integral of x to the minus 3, what's that going to be? Not in this case. Remember, natural log only applies to x to the minus 1 power. So that's a very special rule because that's x to the minus 1 power. So it doesn't apply for other negative powers. I want you to use the rule effectively here, guys. Let's try it, see what we get here. X to the minus 2 over minus 2 plus c. Okay, that's correct. Okay, so we use the power rule here. We have x to the minus 3. Again, you're not doing anything different. If you're thinking that you're doing something different here, you're sadly mistaken. Okay, we have x to the minus 3 over minus 3 plus 1. And then plus c. So if you're thinking this has to be super complicated because it's a negative power, the answer is no. I'm not doing anything different. I'm applying the same exact rule here. So I get x to the minus 2 over minus 2 and then plus c. Okay. Okay, that's seriously, that's all I'm genuinely doing. Okay, I'm not doing anything more than that. Okay. That's it. That's all I have to do for that problem. Okay? All right. Now this time, let's apply number 4. Let's go ahead and try number 4 here. Like I said, lots of examples here today to get you comfortable with this idea of doing integration. Next section here is going to rely on actually doing this out. So, okay, so let's try number 4. Integral of 5 x to the 7th dx. Okay, so let's go ahead and use our first rule here. Our first rule is that we could take that 5 and we can bring it outside. So that 5 is just going to sit there and do not a whole lot until we're done with the integral here of x to the 7th. So what is the integral of x to the 7th? What is that going to be? It's the integral of x to the 7th. X to the 8th over 8? Okay, good. All right. And there's nothing else to really do in that case. Again, for simplification, if you need to simplify the fraction, you simplify the fraction. That's fine. That's all you need to do for that. Simple enough. Okay, good. So that's the answer to the problem. That's it. Legitimately, that's it. Okay, fine. Sounds great. Okay, let's have you guys try another here. All right, this time this one's a bit tricky, but let's try number 7 there. Okay, so number 7 that you can see there on the screen. All right, it's a bit tricky, but we could just go ahead and modify it a little bit and make it a bit easier on ourselves. So again, in this case here, oops, sorry, that to happen. Okay. So here we have the integral of 7 over x to the 8th dx. So what we want to do here specifically is we want to rewrite this problem. Again, something over x to the some positive power can be also written as to the negative power. So we can rewrite this as 7x to the minus 8 power. That's perfectly acceptable. If we rewrite it like this, doing the integral is much, much easier using our appropriate rules. Okay, so let me move this over to the right here. All right, so why don't you guys tell me, what is the integral of 7x to the minus 8 power? Is the integral of this problem? The integral of this problem here, the integral of 7x to the minus 8. Okay, we're missing one part there, both of you, Lewen and Elizabeth. What else are we missing there? Careful. Okay, yeah, we can't forget about that. Okay, so anytime we have an answer here for integrals, unless specified, I'm going to have the plus c there. Okay? So again, you have 7x to the minus 7 power. Again, that's negative 8 plus 7. Again, that's 7x to the minus 8 plus 1 over negative 8 plus 1. Now in this case here, we do have to clean this up a bit because we're going to get negative 7 here. But this has to be cleaned up here because, as you can see, we do have a 7 and over a negative 7 here. So in fact, we do have a simplification to do here. So 7 over negative 7 will be negative 1. Negative 1 x to the minus 7 plus c. You could put negative x to the minus 7, but I'm just showcasing that off here for this particular problem, so you know where I got that from. Go ahead and this off here. Negative 1 x to the minus 8 plus c. Oh, minus 7, sorry. There we go. Oh, it has the plus c already. Never mind. All right. There we go. I guess that's all I wanted. All right. All right. Any questions about that so far? I want to see where everybody's at here. Okay. Does everybody kind of understand what we're trying to do here? Are there any questions so far? Again, if you're lost or confused or anything like that, because I don't hear you guys really speaking up here, so I just want to be sure that everybody's on the same page about how we're attacking these problems. And if you're not sure, I want you to ask now, because this is going to be used in pretty much all of this chapter and subsequent sections. So getting these fundamentals down is going to be very vital to understanding the rest of these next 3 chapters or so, or at least the next subsequent sections. All right, Emma's good, Lee Wen's good, Elizabeth, Ashley, Nick, how are you guys doing? Okay. All right. I'm getting it, but I need to go slow when it's more complex rules. Okay, that's fair. Let's try another one here, Nick, and I think we'll be all right. So again, we're just focusing on basic rules here, just kind of putting it one piece at a time, okay? So essentially what we're after here. So let's look at number 8. Okay, so number 8 says find the indefinite integral, use plus c. All right, fine. So we have the integral of 8 plus u squared. Okay. Again, if it helps you here, and I'll direct this to Nick here, if it really helps you here, put a 1 here as u to the first power. So that way, when you do apply a rule here, it's a little bit easier to visualize, if that helps you in this particular case. All right, so, all right. So again, you could take this as 3 separate individual integrals. Again, you're not doing anything special here in terms of putting stuff together here in like all at once. You can just take it as 3 separate integrals if you like, and you could figure out the integral of each part here and then put it together at the end. So, all right, so I'll let you guys take a 30 seconds, a minute here. Can you guys tell me what the integral of this particular function is going to be? Take a little time here. Make sure we get that down. Let me know when you guys got an answer. See if it works. There we go. Okay, Elizabeth has that. Now you don't need that many C's in there, to be fair, Elizabeth. You could just have the plus C at the end there. So you could take out all the plus C's and you could be like, okay, because it's all a constant number. So you just put that out in the end, the plus C out in the end, and keep everything else. Yeah, because literally C can be any constant number you want. So That's why we just kind of put it out there like, oh, it's going to be that. So, all right, so let's put this together here. Follow Elizabeth's example here. We have 8x. Again, that's a constant number, so we have 8x. It would be add 1 used in the power rule here. Okay, we use the power rule here. So plus u squared, that's 1 plus 1 over 2. And u squared, again, is 2 plus 1, 3. And you put that over 3. Then you add it by c. And there you go. That is going to be effectively our answer to that problem. Okay. Our answer here, let's go ahead and put this in. 8x plus squared over 2 plus u to the third 3 plus capitals. There. Yep. All right, and that's our final answer for that. There you go. Not too shabby. Okay. Let's have you guys also try number 9. And number 9, you will need to simplify a little bit there at the end. So, let's have you guys try number 9. I'm having you kind of go down the list here because of I want you to practice with these rules here. So, integral of 0.9t squared plus 0.06t plus 7 et. Okay. You guys let me know about this, okay? Let me know what this is going to equal to. I'll give you guys a minute here to go ahead and give this one a try. Again, just be sure to simplify your answers there once you got them. So, for the numbers, of course. Give it a try. Yes. It's fan. So if you have an answer, go ahead and post that up into chat. All right. So if you have an answer, post that up into chat, and then we'll see if that's correct or not. Okay. All right, Emma, that's correct. Now, I want you to go one step further, Emma, and I want you to simplify the numbers. Okay, same with you, Elizabeth. I think the mistype was the 10.9 is a mistype, but yeah. So I want you to take the next step after that. Yeah, that's a parentheses. Yes. They're just like the problem. Just no, it's all good. Don't worry, I do this. I know my handwriting is terrible. So I don't blame you in the slightest. Alright, good, Lee Wen. Alright, so again, I want you to go ahead and simplify the numbers, okay? So I want you to do like the 0.9 divided by 3 and the 0.06 divided by 2. Okay, so I'm in agreement with all three of you here. Okay, what you have here so far is absolutely spot on. Alright. So up to this point here, I very much agree. Okay, so up to this point here, I want you to simplify the 0.9 divided by 3 and the 0.06 divided by 2. And then tell me what we get here for our final result once we go ahead and do that. What is the simplified answer? You can use your calculator, of course. All you have to do is do 0.9 divided by 3 and 0.06 divided by 2. .3t to the third, 0.03t squared, plus 7t plus c. Alright, that's correct. Yes. Alright, that is the correct answer. Good. So we did the power rule here on each one of the terms, and then we go ahead and simplify at the very end to get what we want here, which was the integral in this instance. All right, great. Questions about that? I hope that was relatively straightforward. I'll actually showcase. Let me put this here. I'm gonna do some tougher ones here in just a second, but I'll show you that. Oh, whoops! I'm 0.0. I wonder why I got that wrong. I entered it wrong because I'm a dude. All right, now it should be right. All right, there. Wait, I got this wrong. Oh, that should be. I gotta make sure I have such a bad habit of actually entering an X all the time. I remember to put it in the right form. All right, yeah, that worked. Okay. 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 So let's take a good look here at the next one. Is 8e to the x. Well, e to the x is very simple. I'll just do it really fast. This one's super fast. So number 10 requires a line. The integral of 8e to the x, literally e to the x does absolutely nothing. So literally your answer is 8e to the x plus c. Like basically, if you're looking at e to the x, you're not really looking at a whole lot here for e to the x. It literally does nothing. There's nothing that really goes on. And that's pretty much it. Okay. Okay, the next one here, let's talk about a couple of these here. Let's see. Okay. Alright, so the next one here is going to be number 13. Okay, so number 13 here, it says find the indefinite integral. Now, they give you a huge hint for this problem here. It says use c for the constant of integration, that's whatever. But the hint here is that x to the 8th minus 1 over x to the 5th is equal to x to the 3rd minus x to the minus 5. You're probably saying, whoa, 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 time out. Time out for a second. Like, hold up a second. How the heck did they even come up with that? Where the heck does that even come from? It magically came up with x to the 3rd minus x to the minus 5? Like, how? Well, again, to make this problem easier, what we want to do is break this down, right? So if we're going to break this down, this integration, the way we break this down here specifically is we break this up into two fractions. So we take x to the 8th divided by x to the 5th, and we can subtract it by 1 over x to the 5th here. Now x to the 8 over x to the 5, it's just 8 minus 5, so essentially you wipe out 5 x's and you'll have 3 left over. And you can rewrite any positive guy on the bottom and rewrite it as a negative guy if we put it up top. So that'll be x to the 3 minus x to the minus 5. And then you can go ahead and proceed to do the rest of the problem as is instructed. Now there is one thing that you do need to be careful about in this problem, and breaking it up into two fractions, you don't like that? I mean, it makes the problem significantly easier, I ain't gonna lie. I mean, it doesn't look great, but it works. You're like, I don't like these smelly guys. I'm like, okay, I get it. I understand. I mean, it's a little bit of extra work. Yeah, it's a little bit of extra work, but it does make it a lot easier. It avoids work, okay? Sometimes the laziest method is doing a lot of work at the beginning and then automating it at the end. So it's like, if you're doing a job and then you find like the laziest way possible to do that job, you do a ton of work at the beginning to basically do that job and automate it, and then you just kind of sit back and relax and just let it, just let it go, just keep going. You're just like, I'm just gonna do this, and just, how much time does this take me to do my job? 5 minutes? Okay. And then for like the next 8 hours, you just sit there, surf on the computer, in a corporate building. You're like, all right, cool, man. Answer some emails. You're like, yeah, it's done. Yeah. Productive office work, that's me. Pretend to work, collect a paycheck. That's how I look at it. Like, it's the fastest way I can get to where I want to go. All right. Fair point. That's how it works in the corporate world. It's like, okay, if there's not a lot of oversight, you're like, okay, nobody's really overseeing you and they're looking at your productivity. As long as you showcase your productivity, they're like, all right, get my stuff done, give me a paycheck, I'm out. Like, okay, fine. That's what you want me to do. Fine. Like, I would try and do that when I was working in like retail. When I was working customer service, I was always trying to find ways to avoid work as much as possible. Yes, do work to avoid work. Yes. Don't you know? The smartest people in the workplace are the laziest. I know that seems strange, but if you think about it, it's kind of true. People who are the laziest know how to expedite their job as best as possible, thus have the maximum productivity for the least amount of effort. So, I said, if you find a way to make it easier for me, great. You're hired. All right. I mean, you can debate me all day, but it's true. All right, so let's go ahead and do this out here. We got x to the 4th over 4. Okay, if we do x to the 3rd. And then this one here, you have to be a little careful about sign changes. Again, you're going to add. Right, so this is x to the minus 4 over minus 4. But because you have a negative of a negative, this becomes positive. So be careful about sign changes here, all right? Very careful about sign changes here. This will be x to the 4th over positive 4 plus x to the minus 4 over positive 4 plus c. All right, there you go. Easy peasy. All right. Questions so far? All right. I'll let you pick. 14 or 15, guys. 14 or 15. Oh, would be helpful if I showed both of them up. 14 or 15, guys. Which one do you want me to do? Elizabeth says 14. I did just do one of them, so 14. All right, Elizabeth says 14. What about the others here? Lee Wen says 14. Right, what about Emma and Nick and Ashley? You guys, of course, have a say-so as well. Emma says 14. Okay. All right, so it looks like everybody's going with 14 here. Huh. You guys would go with 15, but okay. Bucking the trend on me, you guys. All right, it's fine. All right, so 14. Integral of u. What am I doing? Wow, I was in statistics mode there for a second. U to the minus 4, 5u to the 4th. Again. Plus u to the 8th. du. Okay. So in this particular case, we need to go ahead and distribute the u to the minus 4 to all three things on the inside here. All right. We're going to do the simple thing and distribute. Now, when we distribute here, let's see what we get. We get 5 u to the minus 4. Now, here we get u to the minus 4 times u to the 4th. So if you multiply these together, I'll show you what happens here. When we multiply these together, we technically just add the exponents together. So I'm just going to show this intermediary step here. I'll show the intermediary step for the last one. We take u to the 8 plus negative 4. Okay. Okay. You're probably wondering why this is so important here. Well, simply put, if we do this out here appropriately, before we do any of the integration, 4 plus 4 is equal to 0. So technically we have u to the 0 here. Can anybody tell me here, what is u to the 0 power? What is u to the 0 power equal to? For any letter to the 0 power. 1. Okay. So we have a minus 1 plus u to the 4th. Okay. That's why I rewrote it like that. Do we have to multiply it out, or can we still get the right answer if we don't? Yes, you will have to multiply it out. Yeah, there's no other way to get that answer. You cannot... So one thing you cannot do in integration is you cannot do it with multiplication in regards of, like, I can't split up the integral as the integral of u to the minus 4th times the integral of this whole thing. Like, I'm not allowed to do that. I could do it with addition and subtraction, but not multiplication and division. That's a whole different ballgame. Okay, so when you're talking multiplication division, that is right out the door. All right, we cannot do integration with multiplication division with splitting it up that way. So unfortunately, it does not work that way. Yeah, integration here specifically to your question there, Elizabeth, it is much more rigid than that of derivatives. So in terms of the rules, we have to use them very rigidly in order to actually work with them. So, and you have to be very specific about how you use them. So hence why rewriting the problem here is actually significantly easier. Okay. All right, let's take a good look here at our guys. Okay, so here we have the integral of 5u to the minus 4, which is going to be 5u to the minus 3, not to the minus 5. Some people like thinking, 5u to the minus 3 over minus 3. The integral of 1 is just u. Okay, that's the integral of 1. And then we have plus u to the 5th over 5. All right. That's going to be our answer for this problem here, is once we multiply it here. And then, of course, plus c. I should be, of course. 5u 3 minus 3 minus u plus to the 5th 5 plus. Okay, and that's our final answer for that problem. Okay, so let's go ahead and submit that. All right, and that's correct. Okay, good. All right. All right. Next, let's do the next batch of problems here, 18, 19, and 20. Okay. So let's go ahead and we'll do one of these problems here because it'll just showcase exactly how we want to approach these problems. All right, so these are initial value problems, all right? I put a separate question for that. So how do we solve for initial value problems? Step 1, take the integral of the function given. And step 2, using the x and y value given, we're going to solve for that constant c. So in this case here, to solve for this particular problem here, we are going to actually have to find out what that constant is at the end of our integral. But this is because of the fact of the values that we're going to be given here from the outset of the problem. So I'll have you guys pick, of course, once again, between 18, 19, and 20. Which one of these three problems would you like me to do? 18, 19, or 20? Which one would be the one on your docket here? Which one would you like me to do here? 18, 19, or 20? You gotta pick one, so pick one of them that's on the screen here, and then we'll go and do that problem. You gonna do 19? Lee Wen says 19. All right, Nick and Emma, Ashley, guys, what do you guys want me to do? 19? Okay. Ashley says 20. All right. So by democracy, always democracy. 19 is good. Okay, let's do 19. That's fine. All right, so let's do 19 here. I have this over here on the left. Go ahead and back up here. All right. Good stuff. All right. Let's go ahead and work with what we have here. All right, there we go. All right. So with number 19, we're going to take the initial value problem here. We have f prime of x is equal to 5 over the square root of x. And we're given a condition here that f of 16 is equal to 48. Okay. So the way we want to approach this problem here is first we're going to rewrite this problem. Again, the square root of x here can be rewritten as x to the 1/2 power. But currently we have 5 over x to the 1/2 power. Make this even easier, now I'm going to transfer from the denominator, we'll transfer that up to the numerator. We have 5x to the minus 1/2 power. That's exactly what we're going to take the integral of, is 5x to the minus 1/2 power dx. Alright? That's what we have here so far. Now if we take this particular integral, is what we're going to get here is we're going to get a 5x. We're going to have negative 1/2 plus 1 over negative 1/2 plus 1. And then we'll have the plus c here at the end. So what we have here is we got 5x to the positive 1/2 over 1/2. Now remember, if you divide by a fraction, you just flip that over. So if you divide by a half here, you can simplify this as 10x to the positive 1/2 plus c. So this is what we have here so far doing the integral. So this is just step 1 as part of this particular problem. This is step 1, getting the integral and getting it down. Okay. All right, any questions about that part there? Hopefully that part there is pretty clear about how I got that. Again, 5 divided by a half is 10. So that's where I got that 10 from. Okay, so what we're going to do next is we're going to solve for this letter c. But in order to solve for this letter c, we're going to use this fact right here. F of 16 is equal to 48. So this basically says is when x is equal to 16, y equals 48. That's what it says. X is 16, y is 48. So essentially, this 10x to the 1/2 plus c is going to equal 48 when x is equal to 16. So I can set 48y is equal to 10, the x, which is 16 to the 1/2 power, plus c. Now all I'm going to do is do a little algebra here. So I have 16 to the 1/2, which is going to be 4. 16 is just the square root of 16. So we have 48 is equal to 40 plus c. Subtract by 40. We get 8 is equal to capital C. So our final answer here, because we have 10x to the 1/2 plus c, our final answer here is going to be 10x to the 1/2 plus 8. And this is going to be our final answer now that we solve for c. That is the answer here. Okay, and that's it. Go ahead and check that out there. Okay, questions about that? Any questions? No. Okay. Be sure everybody's on board with that. Okay, good stuff. All right. I'm going to briefly talk about this last problem here for this particular section. And that is in reference to number 24. 23 is just doing something similar here. So we want to talk about number 24 here. I do want to reference that here really quickly. Now, number 24 here talks about velocity of a car. So I want to read this off here really quick. So 24 says the velocity of a car in feet per second, t seconds after starting from rest, is given by the function here f of t is equal to 8 square root of t, where t is between 0 and 30. Find the car's position s of t at any time t, assume that s of 0 is equal to 0. Okay, so this particular problem here is not hard to do, but it's just one thing I do want to remind you about here specifically is in regards to velocity and position and those sort of guys. So we talked about it before when we did derivatives, but just as a friendly reminder here, how does it work? Well, when we talked about velocity here, remember that velocity here is this particular function 8 square root of t. Remember, it always goes in the same order. S of t is position. Okay. V of t is velocity. But remember how we defined velocity. Velocity was the derivative of the position function. So if we're going from velocity backwards to find the position instead, so that would mean that the integral of the velocity function is equal to the position function. Okay? In effect, you're going backwards. Remember, you take the acceleration as just the derivative of the velocity. So it always goes position, velocity, and then finally, of course, acceleration. The last one here. So when we look at questions like this, again, we just have to reference back to that same tried and true formula here. If we're going to go backwards, we're going to have to take the integral here instead. So the integral of the velocity function is the position function, or the integral of the acceleration function here specifically is equal to the velocity function. So you can, again, need to work your way backwards a little bit, again, because that's effectively what we're doing here. That's essentially what is going on in this problem. So we take the integral here of 8 times the square root of t to do the same rigmarole, and you get stuff done. All right, so want to point that out there in that case about how that's going to work. And if I recall correctly, what's the answer to this? Oh, yeah. I think that's the right answer. Test it. Got it. Yep, I got it. Sweet. All right, good stuff. Okay. All right. Okay, very good. Okay. All right, so that is the end of section 6.1. Okay. Now, we're going to start here with section 6.2. I wanted to start with section 6.2 here today because we're going to do some examples here, maybe an example or two, and then we're going to go ahead and look at some more examples here for next time, as we just kind of want to meld it together. But I want you to know these basic rules here first. Of course, we need to know the basic rules here first, but I wanted to kind of transition into this second section here because we're going to directly use these integral rules now in section 6.2. So let's go ahead and do that right now. Save that. Okay. And once again, there's only one question that we'll need to answer here, but the problems here in this particular section are rather tricky, and I want to talk about them right now. Again, now that we have a good basis of understanding, for integrals, even though we have a basic understanding, more so basic understanding more than basis of understanding. As long as we have the basics down here, then we know what we need to be. So let's do that here in this instance. Okay. So in this particular section here for section 6.2, it says, how do we do integration by substitution? Okay. Now let's do an example here because I want to go through the steps here very carefully about how we can explore this particular thing. So let's do that. Okay. All right. So we're going to start off with something simple, and then we're going to ramp up to a second example, and then we'll see what we get after that. Okay. Because again, if you don't understand it right away, that's okay. Again, we're just going to be going slow. So let's go start off with something like this, like number 1, and then we'll see what we're working with. So we have the integral of 3 times 3x plus 2 to the 4th power dx. Okay, so let's put that down. Okay, now you're probably looking at this and you're like saying, whoa, 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 timeout. All right, there's no way in heck that I'm going to go ahead and FOIL out 3x plus 2 to the 4th. I mean, you can, but it would be pretty bad. Okay, it would be pretty long, pretty bad, and obviously would be painful for everyone involved. So we're obviously not going to do that. And then you have this extra 3 floating out here, and you're like, whoa, 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 timeout. What the heck is this? All right, you got this extra 3 floating out here. You got 3x plus 2. I said, this looks like nothing like any of the questions we just talked about in the last section. Like, where are we getting all this stuff from, and what do we do with it? I said, all those very valid questions. So let's look at seeing how we can actually solve for this particular integral. See what we get. So let's look at step 1. In order for us to do this substitution here, we're going to use a letter. That letter specifically will be the letter U. Okay, so let's look at the letter U here. It says define U as part of the integral, the inside function of a composite function. U is equal to g of x. Now, you're probably saying, hold up a second. What do I define U as? How do I know what it should be? How does it even work, okay? Now, the trick is behind this is, how do I know which one's my quote-unquote inside function? What we want to do here is, and I'm going to actually skip here to step number 3 for just a moment, because I want you to kind of look a little bit ahead here in order to understand how we're going to define U. Because what's the goal of this substitution? The goal of this substitution is we are going to rewrite the entire integral. The entire integral. Okay, so that's the goal here, to rewrite the entire integral in terms of this letter U. If we can do that, that means all the x's are gone. That includes the 3x and the dx and everything like that. I don't want any of that stuff in my integral. I want nothing to do with it. So how would I approach it here in this particular case? Well, the way I would want to define it, at least in this instance, is I'm going to set U here specifically equal to 3x plus 2. So you're like saying, now hang on a second, Professor Chips. It's 3x plus 2. What does that do for me? How is that helping me? Okay, let's take a look at step 2, and you'll notice exactly what's going to be happening here in order to rewrite this problem in terms of all u's instead of all x's. Now it says here, find the derivative of u and define it as du is equal to the derivative of whatever function you defined u as times dx. Okay, so I'm going to take du, I'm going to make that du, I'm going to take the derivative of 3x plus 2, which is 3, and I'm going to slap a dx next to it. That's what I'm going to do. Okay? Okay. That's what I went ahead and effectively done. Fine. Problem. All right. Now let's look at step 3. And I'm going to need a couple colors for this. All right. So, we need to rewrite this entire integral, this 3 times 3x plus 2 to the 4th. We need to dx. We need to rewrite that entirely in terms of u's. That's all we're looking for here. So, how does that work? Well, let's break it down one piece at a time. Okay? So really slow, all right? So I'm going to have, first of all, I'll have the integral symbol. No problem. Let's take a look at what's in the parentheses here. First of all, we have 3x plus 2 inside those parentheses. That we defined as u. I'll put that in black. We define that as u. So right now, this is all u, this 3x plus 2. I'm going to take that to the 4th power. Now let's see what's left over. What's left over? And I'm going to put this in orange. Okay, so let's put this in orange. Actually, no, I take that back. Put it in green. What's left over here? But what I have left over here is I have a 3 left over, and I have a dx left over. Oh, well that's ironic, because, well, I have 3 already and dx left already. I have it right here. I have 3dx. And what's 3dx equal to? Well, both of these guys put together is equal to du. So I have e to the 4th du. Okay, so now I have effectively rewrote my integral in terms of all u's instead of x's. Stop there for just a second. Okay, so let me stop there for a moment. Before we move further, are there any questions so far? I'm going to take this one slow. There's a lot going on here. Again, if you're confused about how I got that, I'll go over it again. Can I go over it again? Okay. Let me tell you what the trick is behind this, Elizabeth, and everybody else for that matter. The trick is, really, is to look a little bit ahead into the future and to pick the correct function that's going to help you substitute everything in terms of u. Okay? So let's put that down here as a part of our little... Okay. So I'm just going to go over this carefully here. The trick here, look ahead and pick a function for u in which you can substitute everything in, so you can substitute everything in should say in terms of u. After you take the derivative. So again, we have 2 pieces of the puzzle here, okay? So think of it as kind of like putting a puzzle piece together. We first had to kind of declare what u was going to equal here. U here is equal to 3x plus 2. I said, I can't deal with 3x plus 2 to the fourth, right? I can't deal with that. That's just really hard to look at in terms of any, any integral. It's really, really difficult. So I'm like, okay, let me replace that whole thing with just the letter u. That's what we decided to do. Okay. Then I'm like, okay, well, what's the derivative of u? The derivative of u is 3x dx. And ironically, in this particular problem, we have a 3 and a dx left over. Because again, this black part here that we have is u. Just this part here is u, right? And we have a 3x and a dx left over, and that part there is equivalent to du. Okay. These in their respective color boxes here. So you see how I kind of put these together. U is 3x plus 2. That's where this goes, where this box goes. And du, once we went ahead and found the derivative, remember, du, just to let you know here, all right, let me go ahead and reference this also as well to make it less confusing. Du, or dx, or whatever you want to call it, all right, du represents the derivative of u. All right, if we say dx, that's the derivative of x. Okay, so if you see like d with some letter here, that's the derivative of that particular letter. Okay, so derivative with respect to x, or the derivative with respect to whatever. Okay, so that's basically du dx. Okay, so du here, which is the derivative of u, is equal to 3 times dx, because we took the derivative of x here with respect to x on this right hand side. So all I did was replace this 3 dx with du. So let me show off one more time. This u here is the 3x plus 2 fourth, and this du was the 3 dx left over. Okay. Does that make it a little bit more clear about how I played this substitution game for this particular problem? Are there questions about that? Hope you guys are seeing exactly how I'm doing this little substitution here. Any other questions? Guys, let me know. Let me know here. Any other questions, first and foremost? I'm still a little confused with du being 3 dx. Why is it du? Because we took the derivative of this u here, Elizabeth. So this u, we took the derivative of that. That became du. So that's what we're doing here. When we use step 2, find the derivative of u and define it as this. Okay? That's how we write the derivative of u is equal to something in terms of x dx, whatever that derivative is. That's like the rule that we use here for derivatives, all right? We've been pretty much doing that the whole time. It's just that we don't really write it out. And in this case, we actually are going to write it out. So it'd be the same thing here, Elizabeth, as if I had, say, s is equal to 5x plus 3. Well, I would have su, okay, or ds, I should say, not su. What am I doing? ds. I'm an idiot. All right, equals 5 dx. I have ds is equal to 5 dx. The derivative of s is equal to 5 times the derivative of with respect to x. So again, just depends on the letter. We just use u here as our go-to letter here. Okay? Okay. So u is a very common letter for substitution specifically. Okay. Any other questions before we move forward? Any more questions? Like I said, I'm being really super slow about this because I want to be sure that things are clear about how we're approaching things. So. No? Okay. Alright, so I'm going to move forward here. Alright? Okay, so what's next after that? Well, what's next after this is we need to take the integral of u to the 4th du. The integral, using our integral rules that we learned just in the last section, this is going to be u to the 5th over 5 plus c. So we're going to take this integral here. That's going to be step number 4. We can now just take the integral straight up in terms of u. Once we go ahead and find that integral, in this case u to the 5th over 5 plus c, in this instance we just do the substitution again. We already know what u is equal to. It's equal to 3x plus 2. So we're just going to replace u with 3x plus 2 back again, and then write in our final answer. Our final answer here will be 3x plus 2 quantity to the 5th for 5 plus c. So the trickiest part here is, of course, step 3. The rest of it is kind of a fallout from step 3 here, so it's pretty quick. But it's really just making sure that you do the substitutions correctly here in for steps 1 through 3. So it's always why I have to go slow on that one. I know that that usually is the biggest source of confusion. So, okay, did one problem here. Let's try another. I think I understand your brain is shish kebab fried. I understand that, but you absolutely have to do another problem. All right, and it'll start to make sense. All right, the next one here. Let's do number 3. Number 3 here. Okay. All right. So can we ignore du? Okay, so the way it works is that when you take the integral of du, the du goes away. All right. Okay. You notice that in a lot of our integrals we have dx at the end, right? Notice that it's just in terms of x once we go ahead and take the integral. So like if we, all right, so that's the way we operate in the first section. We said, okay, what's the integral of x to the 5th dx? All right, well, that's x to the 6th over 6 plus c. That dx goes away because you're going backwards here. So, yeah. Okay, so let's do number 3. Integral of x to the 4th minus 3x quantity squared times 4x squared minus 3 in that dx. All right. So we got to pick a function here for u. Okay, we got to pick a function for u. What should u equal to here in this instance? You kind of have two choices here, by the way. So take a look here. Which function do you think u should equal to here in this instance? Again, look a little bit ahead here in this case, because you want the derivative to start, compensating for the other stuff there in the integral. Again, we're trying to rewrite this whole integral in terms of the letter u and du. So what do you think u should equal to? Which one of those two functions that you see there do you think we should have it equal to? Yeah, so I can't, I'm not allowed to do that. I'm not allowed to do that. X squared minus 3, I can't do that, unfortunately. So it needs to be either x to the fourth minus 3x, that's correct, or 4x squared minus 3. I agree. One of those two is correct. Elizabeth, one of those two is correct. X to the fourth minus 3x or 4x squared minus 3. Okay, so you say x to the fourth minus 3x. Okay. Let's take a look at that. Let's define it as just that. Yeah, now you're looking at it, you're like, okay. You're like looking at it like, all right. One of those two has to be true. I said, that's fair. You're right. One of those two definitely has to be true. And you're like, okay, well, how do I decide? Well, I'll show you what happens in both ways, okay? So I'll show you what happens when you pick both. So let's look at the first one here that was selected. What is the derivative of x to the fourth minus 3x? What's that derivative there? Oh, I'm sorry. This should be, sorry, I made a boo-boo. It should be 4x to the third, not 4x squared. My bad on that one, guys. Sorry about that. That's kind of important to the problem. That's slightly important to the problem. Just a smidge. 4x to the third minus 3. Okay, good. Alright, so that's du, right? And then we have dx here at the end. Now, if you had picked the other one, let's say you picked the other one. Let's say you picked 4x to the third minus 3. The problem with this is that du here would equal 12x squared dx. But I can't do anything with 12x squared dx because I don't have it in the rest of the problem. So I cannot pick this one. This one would not work. I wouldn't know what to do with 12x squared dx. There's nothing I can do with 12x squared dx that can make me write the rest of the problem in terms of u. You could try, but you'll find yourself at a dead end very, very quickly. So that's why I'm picking here x to the fourth minus 3x here. Again, you're just looking a little bit ahead here in order to get this to rewrite everything in terms of u. So let's look at our guy here. Okay. Helps you put parentheses around stuff. Let's look at step 3. So let's put our little boxes and stuff. So we have x to the fourth 3x. So that's this. Okay. X to the fourth minus 3x. In our brown box here. So here we have u squared. Okay. And this is u. And this is squared. And now we have 4x to the third dx. We have this 4x to the third dx here. Okay. And as you can see here, 4x to the third minus 3 dx, 4x to the third minus 3 dx. So all of this is going to be du. Everybody see where I got that from? Any questions about that one so far? We're going to finish up the problem here, of course, but hopefully everybody sees how that substitution played out once we selected U and got that stuff down. Make sure everybody's got that. It's a tough. This section here is a toughie, so that's why I'm being very, very methodical and slow and gentle. And I learned this the first time, admittingly. I had a really tough time with it. So. Okay. All right. So if I take the integral of this, the integral of this is very easy. That'll be u to the third over 3 plus c. Okay. Using the power rule we just talked about. And then finally, we go ahead and resubstitute back in our last thing here. So step 5, just substitute u back in. So u is x to the 4th minus 3x, that quantity to the 3rd, over 3 plus c. Okay. That's our final answer for this problem. Okay. Questions? Questions? Any questions? Again, for next time we're going to be looking at slightly tougher problems here, but again, I wanted to go over the basic problems here first, and then we'll look at a problem like number 5 here, which is a slightly tougher version of that problem. I say slightly tougher, mind you. Just means we have to do a little bit more, but the ugly ones are kind of down here-ish, but but I want to at least kind of ease you into this process and doing substitution here, because I want you to see it here today, and then like tomorrow, be like, okay, you had time to digest it a little bit, and then hopefully that when we look at the uglier type of problems, it'll be slightly a bit easier to do. So. That's the grand plan. I'm not gonna lie. That was my grand plan. My grand plan was making sure that you digested it today a little bit, and we get to the tougher stuff here tomorrow. So. All right, everybody good? All right. Everybody's good. If there's no more questions, okay? Any more questions? Any more questions? I'm gonna, like I said, being very methodical for this one here today, in all honesty. Methodical is a good thing, though. All right. Okay. Very good. Okay. Well, I want to thank everybody here for coming on out here to the stream today once again. Thank you all so very much. Thank you for sitting me. I apologize we didn't take a break here today, but I wanted to get through this material. So this particular part of the material I really wanted to get through here, so I absolutely needed to get through here. So I do apologize about that here. So promise to ask you here tomorrow. That's on me. Okay. So we're going to talk more about this here tomorrow. We're going to start on section 6.2. We'll also get into section 6.3. All right, so that's what's on the docket here for tomorrow, and I got a lot of work here to do here for tests and whatnot. So there's a lot for me this week, and I'll be posting that up here later this week. All right, everybody. Thank you, Elizabeth. Thank you very much. You have a very nice evening yourself. Everybody, have yourself a very wonderful evening. All right, have a great night, have a great evening, whatever you want to call it. All right, and we will be back here, same time, same place tomorrow. All right, and as always, ladies and gentlemen, as always, stay safe, stay healthy, but most importantly, stay sane. All right, that's right. All right. All right, take care of yourself, everybody, and we'll see you tomorrow. All right, have a great one, everyone. Take care. All right, bye. Remember, contact me on Discord or on email. All right, have a great one, everyone. Take care of yourself.